Hey now. You think you can help me with a really important experiment?
I'm trying to eat my lunch, and I gotta work out in 10 minutes.
Well, lucky for you, we can incorporate your lunch and your workout.
How? And how would you do that?
Because it's a Freeman test. The only thing is, you're gonna have to eat that same lunch, the same drink, and the same water 3 days in a row. But I can make it worth it while I'll give you $20.
Did you say $20?
$20.
$20? I'm in. Let's do this right now.
Let's get to it.
So what do you want me to do?
Well, you just had that broccoli, so let's see how much you can jump in a minute.
Okay.
Oh, jump in. Perfect. Don't hurt yourself. Good.
Woo! I'm winded.
Winded. That was good. Wow, water. Let's see how much you can jump now.
Yeah.
Wow. Agua. Don't hurt yourself.
I feel empowered.
Really?
Yeah.
More than a broccoli?
Yeah. But how about this orange juice?
Straight out the carton? Gross.
It's 100% pulp.
Disgusting. Now let's see how much you can jump. Jump rope. Ready, set, jump.
Not as good as the water, but better than broccoli.
Really?
Yeah.
Oh, hey. You put your mouth on this, didn't you?
Yeah.
Ah. Well, really appreciate you guys coming. Hope we get those points. Hope we get those extra credit.
Hey, what about my $20?
Happy summer.
What about my $20?
Happy summer.
Hey, bro, I need my
Happy summer.
$20. I need my $20.
Happy summer.
Hey, come back here. So these are the results from the Freeman test we did. Now what we're testing is to see if the workout would be affected depending on what we drink. And we measured this by seeing how many times I could jump in 1 minute with the jump rope. So as you can see, we have orange, broccoli, and water. And this is the data that we received. This is over a period of 3 days. Now, for our first data set, we want to rank them. So as you can see, we have 80, 82, and 83. So out of these, we're going to rank them from lowest to highest. So 80 would be 1, 82 would be 2, and 83 would be 3. Same for this one. 80 would be 1, 83 would be 2, and 84 would be 3. And we're going to do this for all of the data. Now, after we've gone through all our data and ranked them, we're going to add up our ranks. So for orange, we're going to do 1, 3, 3, 2, 2, 2, 2, 2, 1, 1, and 3. Then we're going to do the same for broccoli, and the same for water. And when we add up our ranks, we get 22 for orange, 29 for broccoli, and 15 for water. Then we're going to square that data and get our totals. Total for orange is 484, total for broccoli is 841, and our total for water is 225. Now when we do that, we get our R squared. And with our R squared, we're going to plug it in to this formula right now to get our H statistic. Here is the formula for the Freeman test. The 12 will always be there. The N, K, K plus 1 is for our categories that we have. So as you can see, we have 3 different categories. And for our N will be 11 because for each one we have 11. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're just going to plug that into the formula here. So we have 12, 11 times 3 and 4. Then we have our r squared minus 3n, which is 11, and then k plus 1, which is 4. And with that, we get 8.90. Now, in order to find our critical value, we need to use the chi-square table. Since we're using a chi-square, our significance can be found here at 0.05, which is what we will use automatically for this class and this purpose of the data. For our degrees of freedom, we're going to take our categories and minus them by 1. So because we had 3 categories, orange, broccoli, and water, we're going to minus up at 1 and get 2. Now if we follow here, our critical value will be 5.991. So now that we have our age statistic and we have our critical value, we can start coming to conclusions about our data. So as we can see, our age statistic is actually greater than our critical value. So what does that mean for our data? Well, because it is greater, that means it's significant. Therefore, we're going to have to reject our null and come to the conclusion that what you eat or drink does affect your workout performance.